right. Okay. Thanks, everyone. First of all, I want to thank Jane, Josh, and Margaret for joining us today. They're all space veterans. So without further ado, I want to, maybe give everyone a minute to kind of explain, what does your company do? How do you guys, work? What is the mission of your company?
Good morning, everybody. So I'm Jane Poynter. I'm founder and co-CEO of Space Perspective. And we want to take as many people as possible, unprecedented numbers of people to space, to really open up space to all of us, and to give people what astronauts talk about as this incredibly transformational experience of seeing Earth in space. So we are not using rockets. Instead, we use a balloon that carries a capsule. Initially, our first capsule is for 8 customers and a captain on an initial 6-hour journey to space out enormous windows. If you saw this capsule, it is not anything like you ever imagined going to space would be like. There's a bar on board and a loo and Wi-Fi. And so we're really making this incredibly accessible. It's really safe. It's globally scalable, and it's carbon neutral. And we'll be in operation around the end of next year. We're getting into a full-up, rigorous test flight campaign very soon. And we've already sold 1,650-something tickets. I've lost count.
Wow. Okay. Every single time I see Jane, the number just keeps going up. So I'm very excited. Hopefully, I'll be able to join this journey as well. Next, we have Josh from Relativity Space.
All right. Thanks for having me here. Again, I'm Josh Brost, Senior Vice President at Relativity Space. Relativity was founded in 2015 to do 2 things. Our North Star is really developing the technologies that make it possible for humanity to be interplanetary. And as part of that, we're really developing 2 things. We're developing launch vehicles that make it less expensive to get to space and finally create some real economic competition for SpaceX. And in parallel with that, we're developing the world's largest 3D metal printers. We actually flew a rocket earlier this year that was 120 feet tall, weighed about 150,000 pounds, and was 85% 3D printed by mass. The reason for 3D printing is if you want to have a permanent presence off Earth, you need to build what you need when you're there. You can't rely on a 26-month supply chain. And it turns out that those same 3D printing technologies lead to better products on Earth that are less expensive to manufacture and faster to improve.
Great, thank you. And last but not least, Margaret.
Thank you for having me. My name is Margaret Abernathy. I am General Counsel and Head of Business Operations at Satellite Propulsion Company, Phase 4. I'm also on the advisory board of another aerospace, German and U.S. aerospace company that does laser communication terminals for airspace and ground. But I'm here to talk to you about mostly the satellite propulsion industry because Phase 4 is changing the way you move in space. The technology that once you get to space on your rocket is how do you get around? How do you move out of the way of a kinetic attack? How do you move out of the way of orbital debris? How do you do it without ruining your own mission, right? So the technology that's currently used on satellites, thrusters, was developed during the Cold War. And so much smaller scale, but still the very relevant story is kind of the same story that SpaceX followed, is really changing the way that how propulsion operates and making space, therefore connecting space and making sure that we can do, our satellite operators can do and go where they need to go when they want to move. And so it's really exciting technology. It's an RF, radio frequency-based technology, instead of Hall thrusters. I won't get too in the weeds today on that, although I am an engineer myself in my past life, so I don't mind geeking out a little bit. And also add one more ticket to your, flight to space. I'd love to join on. So.
Right, who doesn't? So first of all, I want to open it up. What do you guys think makes this time so opportunistic for each one of your companies? How do you think timing-wise, given all the geopolitical issues happening, given, perhaps some natural resource issues, what makes this a good time for you guys, for each one of your company at the moment?
I'm sure we have very different answers to that. So I have been in the human spaceflight industry for 35 years. And in all that time, we've been talking about space tourism. Space travel, it's coming. And way back in the day, it was kind of considered a joke, literally. I mean, people who were industry leaders in space were like, really? Are we really going to be taking people to space en masse? Is that really a thing? Yes, it's really a thing, and it's here. So what has happened to make this such a thing is a variety of things. Obviously, it's a lot of tech dev, right? So we're able to take advantage in our company of all kinds of technologies, not just from space companies, right? We're using batteries for it, from aviation. We're using pumps and things and other equipment from electric vehicles. So it's like there's this enormous advancement in technology that is all coming to help the space industry writ large from a technology point of view really push the boundaries and build the space industry as an ecosystem as well. I think that's really important. You're really beginning to see an ecosystem and a maturation in the space industry. And then for us, the other thing, there's sort of several things that's happened. I mean, we've had also, a couple of industry forgers like Blue Origin and Virgin Galactic that have shown the way. Obviously, we think our way is better. Not that we're in competition with them, because honestly, our experience is so completely different. But they really have shown the world that space tourism is a thing, and it's helping create the market. And we're just seeing an enormous excitement about what we're doing from customers. And then lastly, we're also seeing from the investment community, that's also been a huge game changer, is really seeing the investment community step up and come into not just the space investment arena, but in space travel. And, for our point of view from the investment community, the space is kind of getting congested. And I mean that from a market point of view. And it's really competitive. For us, it's a white space. There's almost nobody doing it. So we have this huge advantage and opportunity that makes now the right time.
Well, you guys are bringing the cost of going to space from, I think right now it's around $450K for our other competitor, and now it's like 120. So, I can say yes, maybe, to this now finally. Speaking of which, we just came back from actually a space demo day in Saudi Arabia. We had another space day in Singapore. I just came back from Super Return this weekend. So, with that said, what do you guys think about, why is this an opportune time for rocket technology? Why is it good for, propulsion engines?
Yeah, I'm happy to chime in on this. The time is now. In early 2022, our side of the industry, the more traditional supply chain side of the industry, started getting a lot of attention. It's because it coincided with conflicts going on in Russia, Ukraine. And we all rely on these noble gases that are sourced from large conflict areas, some in the US, but obviously about 75 to 80% of the world's supply is not in the US. And so we talk about supply chain, everyone here is kind of their sub-industry, but when prices of propellant, xenon and krypton, were rising 3 to 10x or just not even available by suppliers, the markets, the government, venture capital really started taking a hard look on the supply chain that is supposed to be supporting, the tens of billions of dollars in space architecture that the U.S. government has put and built, and trying to put into space, but the supply chain is still broken. So this time, we didn't mean for it to happen, but last spring there's been a large growth and a high attention.
If you don't mind, I just want to ask, I'm personally very curious. I've heard that right now is a kind of winner takes all in your space, given the numbers that's happening in terms of competing for this kind of natural resource to build a much more, efficient engine. Like, how do you guys think about your competition, if you don't mind me segueing into this?
Right. So our competition is we're disrupting anyone who's building a Hall thruster, because Hall thrusters have a cathode. They must rely on natural gases. And those that don't, and there are 2 in the space that are US-based companies, 1 or 2 in Europe that are offsprings of large defense primes, don't rely on those rare natural gases. And so when we think about the competition is we can beat them in cost, and also it's a simpler technology, the RF technology. And so there is a lot of white noise in this space a little bit. You're going to see some consolidation in the aerospace market. That needs to happen if we're talking about aerospace. It is a winner or two winners take all, because our customers, government, commercial, don't want to be single sourcing. So it might be one or two, but winner take all.
Got it. Great. So next, we obviously want to know what's happening with Relativity. I mean, you guys are, I think a lot of people have heard about you guys. So what's the latest? Why do you guys think this is the opportune time?
Sure. So I think if you look back at the history of space, a lot has happened just in the last decade that has really changed the game completely. So from the late 50s, when the space race started, until about 2014, space was considered something that was by and for governments. Governments invested all the dollars in developing launch vehicles and satellites. There were commercial applications, but they were like a rounding error on the industry. If you talk to VCs about investing in space, they all would have laughed at you. The joke at the time when I joined SpaceX in 2010 was, it's the famous, how do you become a millionaire in space? You start out a billionaire. No one had seen an exit. No one had seen good returns. And so it wasn't a thing. And then in late 2014, Google and Fidelity came into SpaceX and cut $1 billion check. And that was their statement to the world that we think commercial space is real and viable. And following that check, you've seen lots and lots of companies get funded. You've got Planet Labs down the road from here, that's raised hundreds of millions of dollars. You've got Rocket Lab, in Long Beach that went public, and all these different commercial first companies started emerging. They relied mainly on venture funding and had mainly commercial business cases that started to make sense. For Relativity, the reason we were founded is we saw this happening. We saw on the launch side that, frankly, there's only one competitive launch vehicle right now. It's SpaceX's Falcon 9. Everything else is in distant second place. And so we saw an opportunity to raise private capital going after these new commercial use cases with a new launch system that could offer better economics using a new manufacturing technology. And kind of bringing all those things together, we think it's a super compelling business case. To date, we've raised about $1.4 billion. We've signed nearly $2 billion in customer deals. Again, those customer deals are with commercial enterprises that want to connect consumers with satellites. So those are companies like OneWeb that want to have satellite-based broadband around the globe. And as we go forward, we're seeing very different pools of capital flow into the space. So for people that know the space industry, in the late 90s, everyone thought space-based internet was going to be a thing. And a bunch of companies got money, and they all went bankrupt. Iridium was one. Globalstar was one. Bill Gates funded a company called Teledestic that was one that never even got off the ground. And everyone comes to us and says, why is today different? You fooled us once. Don't fool us again. And as we look at today, those companies all had, were new companies trying to compete with terrestrial technology that wasn't competitive. And they had very small single source funding sources. If you look at who's funding this new wave of satellite constellations, it's not a bunch of startups you haven't heard of. It's capital from Amazon, one of the biggest companies in the world. It's capital from Google, another one of the biggest companies in the world. It's Apple looking at their direct-to-handset capability. It's Qualcomm putting direct-to-handset capabilities in every new Android phone. And so suddenly you have a much bigger source of capital funding this and seeing it as a clear strategic advantage. And that really makes us incredibly optimistic about the years to come.
Great. Wow. That was really, really informative. Thank you. So let's shifting gears a little bit. Maybe we can, think about space travel for a little bit. What made you come up with this idea? And, I saw the capsule, right? It looks like you can have a bachelorette party in there. How did you guys come up with this idea? Go up to space for 2 hours, come down 2 hours. How was what was the funding story like?
So it did start a very long time ago. So my co-founder and I, Taylor McCallum, were on the design team and then on the crew that lived inside Biosphere 2 for 2 years and 20 minutes. For those of you who have never heard of Biosphere 2, this was way back in the day. We were designing it in the 80s. It was, we lived in it. Actually, today, September the 26th, is the day we went in and came out.
For introducing Jane, saying, "Oh, you only lived in space for 2 years." They're like, "No, 2 years and 2 weeks
and 20 minutes." Yeah. So Biosphere 2 essentially is space-based, built right here on Earth. That it was completely bioregenerative. The idea being that Biosphere 1 is planet Earth, and so that there's huge amounts we could talk about with that, but we won't. What I will say from that experience was that it did launch me into what we're doing today, because the experience that Tabor and I had while we were in there was one of really sort of being one with our biosphere. You know, I went into there because I thought it was the closest thing I was ever going to get to going to Mars, and I came out as somebody who went, holy cow, we live on a planet. Look at that. And we actually probably should take care of this planet. So that's what happens when astronauts go to space. They see our planet from that vantage point, and they get at a really deep visceral level that we are, in fact, a singular human family all inhabiting spaceship Earth. So from that, Tabor and I always wanted to take as many people as possible to space to have that experience. And it just didn't really seem to us that rockets were going to make that happen yet. It's just not scalable. People are afraid of them. You need training. There's high Gs, all the reasons that we have called astronauts our national heroes. And so we started a company called Paragon that has technologies on every U.S. human spaceflight vehicle in operation today. And I remember the day Tabor walked into my office and he said, "So what do you think about taking people up to space using an enormous balloon?" I'm like, "That's exactly what we're going to do, because it's incredibly accessible." And we'd had experience at that point. We were beginning to build a project with then Google executive Alan Eustace, to take him up to space to beat the Red Bull Stratos jump, which we did. And that sort of became the foundation of what we're doing today at Space Perspective. And the reason that we wanted to completely reimagine space for people is because people do think of it as, you know, when you see a picture of the Dragon capsule, it's super cool. But people are in there jammed in their spacesuits in this white, austere-looking capsule. And that's really not how most people actually want to go to space. They want to go with their loved ones. They want to have a drink. They want to hang out. So we designed a space lounge.
Yeah, I thought I saw a cold plunge in there as well. I mean, there are a lot of creative ideas.
Yeah, there's lots of things we could do. That's not in there yet. Although I suppose we could. It is very. We can change up the interior completely. So I suppose you could do that.
Great, awesome. So let's also, maybe I can ask some technical questions here. So for Josh, how do you think about the cost of reusable 3D printed rockets compared to the conventional rocket manufacturing? Can you walk us through, how is it different today?
Sure. So just starting with the economics of reusability. So most companies are focused on reusing the first stage of the rocket. Turns out that's 80% of the cost of the overall system. So just reusing that part changes the economics just so fundamentally that it's hard to understate, hard to overstate. And then with 3D printing, it does have an advantage on the production cost of each additional unit, but that's actually not the killer advantage of 3D printing. The killer advantage of 3D printing is the fact that it really eliminates the cost of iteration. In traditional aerospace, you spend billions of dollars up front on your plant and your supply chain to build one thing and build it really reliably. And if you want to change it, you have to throw all that out and start over again. With 3D printing, suddenly all that physical complexity turns into digital complexity, which means the cost of your next generation rocket is just the cost of the engineering time, which is a fraction of the total cost of a normal new product. And a lot of people in Silicon Valley are very familiar with agile software development. In the hardware world, people have talked about agile hardware development for years, but they've never been able to afford to do it. And 3D printing really is the key unlock for that. And so our first rocket may not be much better than the competition, but we can iterate on a yearly basis and keep on finding ways to make it more efficient and more efficient and more efficient. And that really drives that cost curve in fundamental ways.
Great, thank you. Also, from a technical point of view, I remember when I first heard about Phase 4, I thought, wow, this is some really lab science that, we're adopting now in space. We're talking about, xenon, some of these natural resources. A lot of that is manufactured in China. A lot of that is manufactured in Ukraine. How has the Russian-Ukrainian war affected your business specifically?
It's really disrupted it. It's really had our customers and us try to get creative fast, iterate fast, and have a robust supply chain that is not reliant on these noble gases. And so, we're talking about propellant agnosticism or fuel agnosticism, with rely on air, water, iodine, which is sourced in the U.S., are also or favorable nations to the U.S. And so when you work in aerospace and defense, there's, of course, a primary focus to make sure that your supply chain is coming from a secure spot and location for your end customer, because you're sourcing these satellites or need to think about the size, the mass, the various masses of your satellite, the propellant tank that goes on it, 3 to 5 years in advance of actually launching that thing you're going to launch. And so you can imagine that finally, maybe our world, both I think our supply chains are really thinking much more strategically and robustly, but how to get off of foreign sourced fuel. And of course, our plans to go global, right? There's a few maybe nations that we would strategically not be partnering with or selling to, because that is the space that we work in. But we're a friend to all in the end, and so I think they're really the market capture over the next decade for the small satellite industry, and the supply chain that fuels it is massive.
Great. Yeah, I saw that you guys also have some announcements about the new product coming out, Maxwell. So maybe you can just cover that for 2 seconds.
Right. The new product that's the same core technology that's been flying in space since 2021. It's the RF thruster is the core technology. But what's exciting for phase 4 is we're finally displacing on performance and efficiency, the Hall thruster, which I said is that Cold War era technology that works, but it is extremely complicated. It relies on those noble gases. And so phase 4 is very excited to say that its project is now displacing the incumbent technology. And we're in production. So.
Great. So back to Jane. How do you think about we talked about safety issues, right? You guys obviously have, officer from FAA. You have thought a lot about safety. What do you think is the, danger, or maybe how do you think about what happened after OceanGate? What is the, what can we do to avoid that?
Oh, yeah. Yeah, let's talk about OceanGate just for a second. So that was an incredible tragedy that was completely avoidable. Just for context, in the 60-year history of submersibles going into deep ocean, there has never been a fatal accident until then. And one of the reasons is because everybody used kind of gold standard, tried and tested ways of building the submersible and safely operating them. And then, of course, there is the regulatory body in that environment is the Coast Guard, of course. And everybody is regulated by the Coast Guard, who also has a deep body of experience and knowledge. With OceanGate, sadly, they went out of their way not to be regulated. They actually had no regulation, and there was warnings from people within the industry saying that it was unsafe. And there was a lot of warning signs. It was just such a terrible, needless tragedy. So what does that mean we're doing? Obviously, we're incredibly different. If you just think about the operating environment, you're down in deep ocean. You've got thousands of pounds per square inch crushing your capsule for your submersible. For us, we're up in space, and we have 12 pounds pushing from the inside out. So it's like a completely different operating environment in that sense. But perhaps more importantly, we embrace appropriate regulations. So our flights are regulated by the FAA's Office of Commercial Space Transportation. We're already working with them. We know them well. They have a huge body of knowledge. I mean, there are other companies that are forging the path, like Virgin and Blue Origin and the like, and SpaceX. So we're regulated just like them. And there's a lot of standards that we operate to. You know, there's a lot of very well understood ways to design a spacecraft. You know, if you look at what's happened in the history of spacecraft, the capsules themselves, there's never been a failure of a spacecraft in space, ever. So it's a very well understood technology.
Awesome. Great. Well, that's good to hear. And, you know, we always have a question because space, you know, is such a, sometimes people say it takes maybe forever, right? So maybe for all of you here, what do you guys think is the time to market, right? Like, when are you guys taking off? How do we think about 30 rockets? You know, I mean, you guys already have a product, but like when it comes to like really mass adoption, what do you guys think is the time to market?
Okay, so we're, as I think I mentioned, we're going to be in a very rigorous test flight program very soon here. So we're going to be doing a whole bunch of them without anybody on board, which also is really good. It allows us to put the vehicle through a whole variety of tests that you just wouldn't want to do with people on board. So the result is a really safe test program and a very rigorous test program. So we're going to be in commercial operations around the end of next year, and we'll have a single location to start with in the US. But very quickly, we're going to be growing around the world. So obviously, we're looking at Southeast Asia, other parts of Asia, the Middle East. So there's a number of Europe, of course. So there's a number of locations that we're already in conversations with to expand to. And, you know, we launch from a ship, we splash in the ocean, which gives us ultimate flexibility. We can go anywhere. We can launch from pretty much any ocean. So that gives us the ability to scale really quickly. We're completely vertically integrated. So that means we build our own capsules, our own balloons and the like. We do buy off-the-shelf parts, as I was talking about earlier, where they're appropriate. That also allows us to scale quickly. So we are going to be starting the first year off a little slowly, you know, something like 50, 70 flights in the first year, but then growing very quickly after that.
Josh, please, what is your time to market for Relativity Space?
Sure. So as I mentioned earlier, we flew a demonstration rocket earlier this year. And I think of that as really our concept car that proved what could be done. And now we're moving all of those technologies into the larger platform called the Terran R. So just for a sense of scale, Terran 1 could lift about 1,000 kilograms into space. Terran R can lift 20,000. So it's much, much larger. You're talking something the size of, you know, these large 777 aircraft, you know, kind of things. That will enter operations in 2026. And as I mentioned earlier, we've already signed a couple $1 billion in deals to use that system. So the first several years are already sold out.
Awesome.
Right. So products in space right now, latest product, biggest one, you know, next year, right? But 2026, interesting you mentioned that because for our defense customers, that's a very important year. So very separately, but still relatively, is there's some big deliveries for the government that a lot of us are servicing. And so there's a lot of exciting things to come. Scale that keeps us up at night, of course, as we serve the mega constellations that are coming online in the next 2-3 years. And the decisions are being made this fall, right? And so that's where a company like Phase 4 looks outside of the U.S. borders for production, being closer to our customers, and integration. So
great. So we're gonna do a fire round. So, you know, anything we wanna bring up to, you know, remind the audience, right? What is important today in space exploration, in space travel? How do you guys think about, you know, what are the biggest challenges as the last question for the panelists?
Well, obviously, we're focused on getting to commercial operations as quickly, efficiently, and completely safely. That's our 120% focus.
Safety it is.
Yeah, I don't think, look, safety obviously is an incredible focus. I don't know that I would say it's a challenge per se, because I have a 35-year history in human spaceflight, and we got all of the, you know, processes in place to make sure we're safe. But you certainly don't want to rush things.
Right. Thank you.
So I think for us, you know, having developed and flown the small rocket earlier this year, we've really proven out all the different fundamental technologies and analytical capabilities we need to bring our product to market. That said, developing a really large rocket is a massive program, and so it's mainly an execution risk for the next couple of years. We've proven the technology. We've proven the all the different skill sets and even the teams that we need to do it. And it's really just a question of how fast can we bring it to market, because customers want it yesterday, and it incentivizes us to push the team to go as fast and efficiently as they can.
I mean, echoing all of those sentiments, we'll add reliability. When you've got products that are already in flight, they need to now work every time, right? And so our test demos are done, and delivering, whether it's communications terminal or propulsion unit, it needs to be reliable, and it needs to be on spec, and it needs to be delivered on time. And so that's the delivery and execution for the customer, large and small, is our priority.
I just want to close this panel off with, we've seen a lot of billionaires, right, plugging billions of dollars, and now we see, more and more even attention from everyone who is fascinated with space, right? And we're very excited to see companies like, Space Perspective, Phase 4, Relativity, actually creating products that works. So again, thank you guys for participating, and we can't wait to join you guys in space.